Hi friends, so today in this video I am going to discuss the lead code problem subarray sum equals k. So first look at its problem statement. That is says given an array of integers, the integer array name is nums, and an integer k, and what you have to return is a total number of continuous subarrays whose sum equals to k. So let me explain you the problem statement in detail. In this question, we are given an integer array that is nums, and an integer k. So we have to find the total number of those subarrays whose sum is equals to k. That is simple, right? So, for example, in the input test case given to us, example one, we are given the nums array as 1 1 1, and we are given k equals to 2. So, in this, the two subarrays are possible. In this nums array, two subarrays are possible whose sum is equals to 2. Which are those? That is the 0 and 1 index array and 1 and 2 index array. Right, so these are the two subarrays possible. Similarly, for take the example 2, that is 1 2 3, and in this the target sum is k equals to 3. So here also there are two possible subarrays, that is 1 and 2, and also the single element 3. So the example, I hope it is clear to all of you then. Okay, if any doubt comes, please share it in the comment box below. So here are the constraints on it. The array length, that is nums length, is between 1 to 2 into 10 to the power 4, and the individual elements of the array are between minus 1000 to plus 1000, and the k is in the range of minus 10 to the power 7 to 10 to the power 7. So how do we attempt it now? We will use simple hashing. So let's approach it first. So here is the approach and algorithm for the problem discussed just here. Subset array sum equals k lead code problem. So the prerequisite of this question for this approach is prefix sum array and hashing. As we know, prefix sum approach equation, which states that the sum between two indexes I and j is the equals to the sum till jth element minus sum till ith element, right? As we know this equation. So in this question, k is our target sum. So we will be assuming sum of ij to be k in this equation, and hence the equation can be rewritten as 0 to sum till ith minus equals to sum till j minus k. This is simple maths, right? So what we will be doing in this approach or code is we will be taking a prefix sum, initializing it be is with 0 in the starting, and the prefix sum will be incrementing with the nums element, array element, upon each iteration, right? So when we will be running a loop from 0 to n, we will be incrementing the prefix sum with the nums of j. We will be seeing it in the code later. So after that, the prefix sum will be calculated at the index I. We will be After that we will be checking it with the whether the current prefix sum minus k is present in the hash map or not. If it is present, then we will simple increment the count by its map value. And what we will store in map or hash set, we will store simply the prefix sum as the key, and its value will be its count. For example, suppose I take an array of 8 elements, and suppose I'm giving you just a glimpse. We will try run it later. Suppose take it array of 8 element at the index 3. Suppose the prefix sum till index 3 is 5. So we will store the 5 as the value key in the map. The key will be stored as 5, and its value will be now 1, right? After later iterations, suppose at index 7, the prefix sum now again reaches 5. So we will increment the previous value by 1. That is previously the map of the map value of the key 5 was 1, so we will increment it to 2 now. So after the seventh index, the map value of key 5 will be 2. So this is the hash set, or the hash map will be maintained. And simply we will be traversing from 0 to 8, and we will be checking whether the prefix sum minus k is present in map or not. If it is present, we will be incrementing the count with its map value, and after that, upon the loop is completed terminated, we will be returning the count value. So here is the algorithm. Take a look at it, and now I'm going to share with the code and also try run a test case. Okay, so here we will be try running the approach discussed just few minutes before for the question. So we are given the nums array is given to us as 111. We will take an example, a sample test case, that is 111, and here the k is 2. So we will be taking in a hash map and initializing it with 0 as the key and its value as the 1, because subarray set also involves the empty subarray. Empty subarray can also be included, and the sum of empty subarray is 0. So we will be initializing it with the 0 as the key and its count as the 1. So hash map will be initialized like this, and we will be taking a prefix sum variable and initializing it with 0. So we will be running loop, a linear loop from 0 to 2. 2, that is the nums array size. Okay, so in the first iteration, the value of j is 0, and we will be calculating the prefix sum. The previous value of prefix sum is 0, and adding it to the current nums value, that is 1. So 0 plus 1 equals to 1. It is my current prefix sum value. Now I will be checking prefix sum minus my target variable, target sum, that is k. So it is my 1 minus 2. That comes out to be minus 1. So minus 1 is not present in hash map, so we have to do nothing, and we will simply insert the current prefix sum in the hash map. So insert current prefix sum value is my 1. So insert 1 in hash map as key equals to 1, and count of 1 is, and the value is 1, because count of 1 till here till now is 1. So hash map will now be updated. Let me update it. Let me chalo let me write it again. Control C. So now hash map is updated as 1 comma 1, right? Again, in the next iteration, j equals to, in the second iteration, j equals to 1. Prefix sum value now becomes 1. One was the previous prefix sum value, and now 1 is my nums current value, nums element value, that is at index 1, and nums of 1 is 1. So now prefix sum calculated is 2. So again, same step, we will be searching whether prefix sum minus k, that is 2 minus 2 equals to 0, and 0 is present in hash map. So we will be incrementing, yeah, take another variable count at the start. Count equals to 0. So here we will be incrementing count plus equals to the value of hash map of what we search, 0. So 0, the value of for 0 is 1, so count will be now my count equal 1 now. And we will be insert pre-sum current value is 2 as key, and count and value as 1. So hash map will be updated now as 1 comma 1, my last iteration, third is j equals to 2, prefix sum is equals to 2 plus 1, 2 prefix 2 previous value and 1 is the current element, so it comes out to be 3, and prefix sum minus k equals to 3 minus 2, that comes out to be 1, and 1 is present, 1 is present in the hash map. So increment count count plus equals to the current the value of the hash map of the, what we searched, 1, so count new value will be 2. So here all our iterations are ended and the final value comes out to be count equals to 2. We will simply return this count and here is our answer. So hope you all have got the approach for it. Now we will be looking at its code. So we'll be looking at the code. So here I'm going to code it. Okay, so let's take a variable count equals to 0 and prefix sum, it also equals to 0, right? And we will be taking an map MP, right? Okay, so we will try seeing it, and yeah, another iterating variable. Here is the loop. Inside the loop I'm going to calculate the prefix sum, so prefix sum plus equals to I. So here is the lead code format in which the function is my subarray sum and I have to return the integer type, right? And here as the parameter I am provided with is a vector with that is nums, and another target sum that is k. Okay, all right. So in the loop body prefix sum is incremented as I told you approach. Now I will be searching with mp dot find sum minus k is not equals to mp dot, and then simply I one thing I forgot, that is to initialize the map with the value 0. The key is 0 and initializing it with 1. Right. So initialize it, and if the it is found, simply my count will be incremented by mp of prefix sum minus k. At last I'll be inserting the current prefix sum in the map, mp dot mp of prefix sum running. So here is the code. What I have done here is taken count variable prefix sum. I've taken the map mp. This is a int I is iterating variable for the loop, and I have initialized the map with the key as 0 and its value as 1, as I have told the reason earlier in the logic discussed. Here is the loop body, and I have calculated the prefix sum by incrementing it with the previous value and the current nums value, and we are searching prefix sum minus k in the map. If it is present, then we are incrementing with its value, and at last we are inserting the prefix sum in the map, and after this iteration we are returning the count. So let's run the code. Yeah, it's accepted the base test case, as you the base test case was given to as 111, and its output, my code output is 2, and expected was also 2. So let's submit it. Yeah, It's accepted now. Success. 232 ms is the runtime. That is faster than 10.19% of C++ online submissions, and memory usage is 38.5 MB. So thank you. You will be finding more lead code problems, more GFG problems, more DSA problems on this channel. Support, like, share, and subscribe the channel. Please give your feedback in the comment box also, as this is my first video. So please give the feedback as well. Thank you, thank you, thank you, thank you very much.